welcome everybody. Stand up. Our talk is today about, basically it's a double feature extended cut, and it's usually a 2-hour talk, but we only got one slot today, so we need to little hurry a bit. And well, my name is Stefan Köhler. I'm known as a geek man, and this is Hartem, and he's known as a weed man, and we have shirts so that you know everybody who is it. And so let's start, so that we don't lose any time. So that's me. I will just skip the slide. So there's a, yeah, we don't have time today. So this is the agenda for today. We will have a look into Oracle events, and so basically about the Oracle kernels, debug, diagnostic, and tracer infrastructure. This infrastructure basically consists of 3 APIs. So one is the numeric events. That's the old event stuff that you maybe already know. It's implemented in the kernel with C functions which start with KS or dbkd. Then we have the events++, which is also known as a generic debug API. And C functions are started with a dbgd prefix. And there is also kernel server trace diagnostic framework, but this is not directly related to this new diagnostic tracing infrastructure. But we will cover it briefly because the Uts interface can use this KSD diagnostic infrastructure. And then we show how to list and disable events. And maybe if you have time, we'll also look at event propagation. But I already did a talk about event propagation 2 years ago at POUG. And so maybe we skip it based on the time. Okay, introduction into Oracle events. Basically, the events are built in Oracle's low-level kernel debug diagnostic tracing infrastructure. And Oracle has started to re-engineer this whole low-level infrastructure with 11g. Before 11g, you just set numeric events, and that's it. But with 11g, it was totally newly instrumented and developed, and now you have these 3 APIs. In general, events have 3 different main purposes. The first one is create additional diagnostic data. An example is like the well-known SQL trace event 146. You can also change Oracle behavior or work around a specific problem with these events. For example, like disabling turboscan or enable turboscan because there were some bugs with compression and so on, or enable or disable hidden or undocumented features. So that's basically just what it is. And now let's have a look into the different APIs. The first API is the old numeric events-based interface. And the event syntax is based on something which is called kernel service debug. The abbreviation is KSD. But you need to know Oracle no longer adds numeric events to the Oracle kernel. Nowadays it uses a new interface, which is UTS. But the old numeric events are still there and you can use it. But sometimes these old numeric events, for example, like the SQL trace event 146, are mapped to an event++ under the hood. So basically if you use this old syntax and this old number format, in the background it's already mapped to SQL trace. Okay, let's skip this other one because we don't have time. The syntax is pretty simple. You set order system or order session set events, and the first thing you do is event number, and this is basically when the action should happen, right? You can set it on an Oracle error or for some specific tracing stuff. The second one is a trace, and this trace name or this trace syntax is used for tracing, ordering, behavior, or dumps. So this is a general syntax for it, and this is mostly for when you use it. Name is always used in context with trace, so there's another option to do it. And the next one is the context, which is an action. With context, you say you want some specific trace actions. For example, like if you set it for SQL trace event, it will just trace a SQL stuff in a trace file, right? But you can also do something different, not only context-specific stuff based on the event number. You can also do some crazy stuff, which is available via Aura debug dump list. So for example, like creating error stack traces or shutting down Oracle or whatever, everything is possible, or mostly everything is possible with it. And the last ones are some options, which are called forever or the level, which means you can specify the duration. So basically, how long should you trace, or at which level? So how many information do you want to trace? So now it's a little bit demo time. I pre-recorded all the demos because we don't have time, and I hope it works like it should. So I will explain what it does. just wait a second. Okay, so let's start. At first I created a user test, which is not really fancy. I gave him some rights. And then I created one table, which is called tXML. We will use this tXML table later on because of some Aura 600 bug, which we try to troubleshoot. And then I load some XML document into this table. So this is nothing really fancy, right? And that's just the XML contents that you see here. So then I created another table, which is called T1, also not really fancy, and I created a unique index on this table. And so what I will do right now is, as I created a unique index on this table, when I try to insert some values that already exist, I will get an Oracle error 1, right? Something like this, unique constraint violated. And with this syntax, you can do now specific stuff. And in this case, for example, like if I hit some Oracle error, in this case Oracle error 1, I want to dump an error stack trace. So, and this is the syntax here. You say at which event should this action or this tracing happen, in this case an action. If Oracle experiences Oracle error 1, we will do an error stack trace at level 3 and forever. This means every time you hit an Oracle error 1, you will get an error stack trace. And I will show you how it looks like. So I have a second window on my database server, so it's a trace file, and this is how error stack trace looks like. Right? As you get all the C functions and all the call stacks and so on. And every time I hit now this Aura 1 error, one trace file is generated, right? Or error stack trace is generated. So it's the second time, third time, and so on. So your file system gets full pretty quickly. And if you want to troubleshoot such an error, you need just one error stack trace and not a lot of it, right? And so one of the options is pretty useful. For example, like you just want to dump an error stack trace only 2 times. And so you can use a little bit of an advanced syntax. So this is syntax. You should also say on Oracle error 1, I want to dump an error stack trace at level 3, but only lifetime 2. So only 2 dumps are created. So let's have a look. That's the trace file, right? 1. So it's not created anymore. So basically just worked, right? So I said that you can also list the available actions. In my case, I have done some error stack trace, but there is much more what you can do. There's a whole list of it. Unfortunately, there's no explanation with it, but later on we will use Aura debug. And with Aura debug, you get an explanation for all this stuff, what it is doing. Right. So what you also can do is you can associate multiple actions with such an event, right? Now we have only dumped an error stack trace, but we can do several actions when we hit an Oracle error 1. For example, like, I will show you. right? So in this case, I will dump an arrow stack at level 3 only one time, and then I dump some call stacks as well, but only 2 times. And in this case, it doesn't really make any sense because the call stack is also included in arrow stack trace, but I just want to show you the flexibility of this event syntax, right? So let's hit it once again. So I got an arrow stack trace again. And at the bottom, here I have an additional call stack trace, right? So, and the next time when I hit this arrow, I should not get an arrow stack trace again because I have a lifetime only 1, but I should get a stack trace again. And you can see here, that's my second stack trace. So I scroll up, that's my first one. That's my, so the second one comes here, but there is no arrow stack trace in between, so the syntax worked. Right? So the last one is just a little bit of fun because you can also set this level stuff in hex format. So just for the geeky guys under you, you can use numeric or hexadecimal. That's also possible. So that's this one. The next one is events ++ interface. And why was it rendered? Well, you have seen the event ++, the old event numeric stuff. You can say that you want some specific action on an Oracle error or whatever, but if you can only enable it on a session level or on a system level, right? You cannot filter it. I only want to execute it for some specific processes or for some specific SQL ID or whatever. So that's the reason why these events was implemented. And the next API is called events ++, and it's much more flexible and powerful because you can filter it, you can set scopes on it, and so on. And the C functions, how it's implemented, will show Hartem, how it works under the hood. And I will just show you the high-level stuff, how you can set it and how you can get documentation about it. So let's do the next demo. And if you ask, is this really useful? Yes, it is. I also had several clients cases with me, so if you want to see how you can use it in real life, just come to me after the presentation and I will show you the cases and explain it to you. But unfortunately, this time I cannot show it because of the time constraints, right? So the first thing you do is Aura debug. Aura debug is the best tool to get internal information about it, and Aura debug doc for documentation, right? And so you see the events. And as soon as you use Aura debug doc event, I'm sorry, I'm just going a little bit up. You get more information about how to set it. And the syntax is also pretty simple, if you know how to set it. Basically, it starts with the event ID, and the event ID is event name. What event name you have available, I will show you later on. Then you set some scope, some filter if you want it. So scope and filter are just optional, and the actions maybe are optional depending on what you try to do. So let's go for each option and check what's available. So the first thing that I need to set is the event name, right? So here, event name. What I can do. So here also have examples in the documentation already. So that's all you can do with the event ++ stuff. And it's already a lot. You also can see where it is available, if it's in the database library or in the client library or whatever. And you can also see a pretty well-known one, SQL_trace. So that's a new implementation of the old 146 event in the events ++ interface. And we will focus on it because it's the most well-known and we just want to know how you get more information about it. Right? So you say Aura debug doc event name SQL trace, and then you get more information about what you can set. In this case, of course, you can trace binds, waits, and so on. So basically, it's the same stuff that you can do before, but it's a new interface. And the next one you can set is the scope. So the scope option is pretty simple. You only have one option. It's SQL. And when you want to get more information about the scope is you say aura debug doc event scope SQL, and then you can limit it to one SQL ID only. So you don't enable SQL trace for the whole session or on system level anymore, but you can say just trace me this SQL with the SQL ID. Right? The next one is a filter. The filter is a little bit more complex. You can also see which libraries you have filtered. And for example, that's an example I used in a client case. That's the reason why it's in this demo. You can, for example, like only fire this event or this action if some specific C function is on the stack, right? So that's more for troubleshooting purpose. And if you want to know more about information about this filter stuff, you can also use aura debug. And the last one is the action. So basically what you want to do when you hit an Oracle error or some tracing stuff. And the list is also pretty long. And here we get an explanation for all the tracing options. Before, with the aura debug dump list, with this old numeric event interface, you had no documentation or information about it. And here you have. So it's also pretty long what you can do. So you have to check it on your own for your specific problem if you can work around or troubleshoot it with this one. So let's see how it works. I want to have a SQL trace enabled, but just for one specific SQL ID. So I say alter session set events, SQL trace. Then I set a scope on this specific SQL ID, and then the weights, juice binds, and so on what I want. And now let's at first execute a different SQL with a different SQL ID and check the trace file if we have something in it, right? So there's no trace file, so the scope has worked. And now let's execute a SQL with the corresponding SQL ID. And now we have it. There's a little difference between the old and the new implementation. If you look really closely, you can see that you have no parse call here. So as soon as you use such a scope, the parse line is missing. So it's not 100%. And you will see all the recursive statements. These will be in the trace if you have to do some hard parsing and some dynamic sampling or whatever, but you're missing the parse line. So unfortunately, maybe it's a bug, but yeah, that's how it is. So that was a demo about events++. So let's just check briefly what KST is. As I said, KST is not part of these APIs, but the UTS interface can use KST. KST was initially invented for Oracle RAC because when one node crashes or whatever, you wanted to have some diagnostic information about it. And it's basically just an in-memory ring buffer, and some processes are already populating tracing information in it without by default. So this feature or this infrastructure was basically invented because of Oracle RAC in case of some problems. And this UST interface can use this infrastructure. I will show you just quickly how you can get more information about this infrastructure. Okay, at first, basically it's enabled by default. It's also enabled in a single instance. This is a single instance database here. And the parameter which you can control is trace enabled. Basically, it's true by default. And then you have some crazy underscore parameters where you can set the buffer trace sizes per process and so on. And this in-memory ring buffer is stored in the shared pool. It's in the SGA. So just move it here. And you can query this ring buffer with $trace. And I just run a select star, and you see already in my database, I have a lot of information about it from different processes and different sessions. So that was just a query, right? And you also can see the component from what it comes, which C function populates this information, and the data basically is the trace data. And if you look really closely, you also can see already something like this, right? Some weight events are already published in this in-memory ring buffer. So that's how it works. And in case of an Aura 600 or so, these in-memory buffers are dumped into the trace file. So Oracle maybe have some more information about the state of the process, or if something failed already before you hit an Aura 600 or whatever. So that's about this KST infrastructure. And now let's go to the UTS interface. It's already also documented in Aura debug. And that's how Oracle adds new tracing events or new tracing possibilities. That's the interface you need to go when you have to check. Maybe you hit an Aura 600 and get a stack trace, and you see a C function on top, and maybe you want to know more about it, want to trace the C function or whatever. So the UTS interface is to use when you want to more trace information. And this is the only interface which can also populate information in this in-memory buffer from the KST interface. And I will show you this in a short demo. So once again, Aura debug. And if you look really closely, the UTS API is implemented through the events ++ interface. Because Aura debug doc event name trace, you can see main event to control UTS tracing. So you control UTS through the events ++ interface. And that's what you have to set when you want to use this interface. Well, basically the component. What the component is, we will have a look in a few seconds. And then you have some options if you want to trace it only to disk or to memory. So memory is this in-memory ring buffer from the KST infrastructure and some other stuff, right? So the components that you can set here are also documented here. You have a lot of components that you can trace. And the short terms in the brackets, for example, like this one here. If you want to trace streams, you have to set this one, for example, and then every C function that starts with KOXS is instrumented with this tracing information, right? So this is how you can get information about it. So the list is pretty long, because the kernel is instrumented very, very well. And in my demo, I will just use a SQL compiler, so the old CPO tracing stuff for showing you how it works. So you can also just limit it with Aura debug doc component SQL compiler. And you see under the SQL compiler component, you have several other options to trace. For example, like if you only want to trace SQL plan directives or whatever. Right? So in my case, I want to trace everything that's under the SQL compiler, so basically the whole subtree of SQL compiler, and only for a specific SQL ID and to disk. Well, that's the first option. I just want to create a trace file. And let's have a look. So basically that's a CPO trace, because everything that's under the SQL compiler, but it will contain a little bit more than just a plain SQL trace, because the subcomponents are more instrumented than just a simple CPO trace. So let's run the SQL. So here you see, I will go completely down, and so I will scroll a little bit up so that you can see the normal CPO trace information. So that's usually what you know, right? The total scan CPU costs and then the cardinality estimations and so on. But if you look closely, you see more information, like, for example, like these lines, KKFD, pay, RM, and so on. And these are the tracing information from the other C functions, which are on the SQL compiler stuff. Right. So it includes now much more than just the normal CBO trace. So, and the next demo is I don't want to trace it to disk. I want to trace it to memory, right? And so I said disk disable and memory equals highest, and so it will trace the C function stuff into this KST interface or infrastructure. So that was my query, and afterwards I directly queried $trace, and now you see all the SQL parallel compilation stuff, the C functions, and so on, the tracing information. What was previously written into a file is now in this in-memory ring buffer, right? And now some little fun part. And now we'll run a query on my XML tables that I created at first. And this query will result in Aura 600. And when you get this Aura 600 here, right? So Aura 600, blah, blah, blah. And as soon as you hit an Aura 600, I said, an error stack trace is generated. It's the default action of an Aura 600 by Oracle. And with an Aura 600 error stack trace, these KST buckets are also dumped in the trace file. I just wanted to show you how you can find it. So basically you go into this error stack trace file. So that's a normal error stack trace. And just search for KST. So here, KST. And then you will find something like dump KST buffers, and then this in-memory ring buffer is dumped into the trace file as well. So that's how it was invented for RAG, because when a process crashes or an instance crashes, that you can dump this in-memory ring buffer to a trace file and has this information afterwards. So one more little thing. You also can dump this in-memory ring buffer by hand. For example, with Aura debug, dump, KST, dump, and so on. And there's a bug, unfortunately. If you create an error stack manually with Aura debug, dump, error stack trace, or with an action when you set an event, these KST buffers are unfortunately not dumped. So that's a bug from the implementation. But if you dump it manually, this KST buffers only, it still works. Right. Okay, so this was this one. I'm pretty good in time, so you have 10, 15 minutes left. 2 more minutes? Then you have 15. Then you have 15 minutes. I mean, it's just 28. So how to list, disable, and set events? So we are good in time. You have basically 2 possibilities: DVMS system package and or debug. My recommendation is never use this DVMS system package because it's outdated and does not work anymore like it should. I will show you why quickly. So I will set events on a different level, sometimes a session level, sometimes a system level, and I will use the old numeric API, sometimes the UTS, and sometimes the events ++ interface, right? So the old event on session level, the numeric event, then a numeric event on a system level, basically the ones that we used in the first demo, then another one on the session level, and on a system level is UTS trace. And now we use the DVMS system package for getting more information about which events are set. And you'll see it shows only event 1 is set at level 1. But we have set a lot of more events, right? And even this information is wrong because we did not set event at level 1, we set event at some specific action to do an error stack trace, right? So even this is wrong. So you just use or debug and everything is okay. So if you use or debug, dump the event system, you see all events on a system level. And if you use or debug event dump a session, you will see all which are all set on a session level. And if you look really closely, I said we use this old numeric event syntax for setting SQL trace, so the 146, but you don't see 146 in this list, right? And that's the reason why I said all of these old numeric events are already mapped to the events++ interface, and you see it here. So that's basically the numeric events that we set, but it's already mapped to the new events++ interface. And how to disable all events? Yeah, well, just set it off, and then no events are set anymore. Okay, so this demo is done, this is done, this is done. So last slide, then it's Artem's one. I will don't do the demo for the event propagation. Basically, it's just when you set an event on system level, that new sessions and existing sessions are getting this event. Unfortunately, this event propagation is broken in 12.2. So if you set an event on system level, existing sessions don't get this event. So there are two bugs owned, and it's fixed in 18C again. On 11G it works, but it's broken. So if you want more information, you can just check these bugs and so on. So, and now it was pretty high level. How is it implemented really in the C code? And that's what the weakman does now.
Hello. So I think it's time for the second part. So Stefan already have done a great talk, a great presentation about the different available event API, and now it is time to hand them. So in this part, we are going to see how to build an event mapping file in about 10 minutes, more or less. So it will be quick. So what's an event mapping file? So basically in this part, this event mapping file is basically a file where we're gonna find every kernel function, and in front of every kernel function, we're gonna find the actual event which is checking on it. So to do that, we need basically two things. You need to know the actual function that is used for checking for enabled event, and the second thing is that we need to know the actual event which is checked on this function, by this function. Okay, but before going into much detail, let's see why we wanna do that. So basically, using the event mapping file, we can quickly simply extract checked event in any kernel function. So this can be very useful for internal research. We can also decide to extend this and build an event sniffer to display all the events checked in a specific execution path. For example, whenever you execute any statement, select from dual or any statement you want, it can display all the events checked in this execution path. Or if we want to focus only on hotcode path, we can build a flame graph. So we can have a flame graph annotated with the actual event checked in every kernel function. So we can quickly know if there is some diagnostic event that you can use to jeopardize inside this function. Another completely different use case will be to discover undocumented events. Basically, these are the events that are not even displayed in debug event name or debug compound names. That's hidden secret inside the Oracle executable, and using event hunting, we'll be able to find them. So, but basically, I will not be able to describe how I did this in this presentation in 10 minutes. So, sorry about that. And the final result, because it's fun. I'm doing diagram because it's fun. So, looking this kind of thing. So, before starting the hunting, let's begin with some warming up. So, as I said, there is two things that we need to know. The actual kernel function that it's using for checking enabled event, And Stefan already have talked a little bit about the different API. And the second thing that we need to know how to extract, you need to know the event checked by those functions. And for that, we need to know how to extract function parameters. So for that, we need to know how parameter oh, sorry for that. We need to know the parameter passing convention for our binary and our target platform, basically. So this is very detailed in application binary interface. So at low level, actual parameter can be passed by register or pushed in the stack, which is special memory area. So let's take a look at that simple C program. So here you have a simple C program that adds 7 value. So we have 1 to 7. And you can, when you see the assembly code, you can check that easily that the first 6 parameters are saved loaded in a specific CPU register, and the 7th argument is pushed in the stack, RSP, that's for stack pointer, the 7 argument. Okay, so now that we know how parameter can be passed, where they are stored, it is easy to write a tool using, for example, a GDB command or using any dynamic tracing tool to extract those parameters at runtime. So here in this case, for example, I'm using a GDB command to display all these parameters at runtime. So basically that's all we need to start our handling. So it's now time to take a look at the big O. So Oracle, after all, is only a C program with about 25 million lines of code. So some Oracle guys describe it as an horror, so imagine it not having the source code. So basically, I'm gonna start with a simple case, which is the old event API. So in the case of the old event API, it's pretty easy. So for example, here we have the director of function, kernel function, that is calling the check event RDBMS error, and the event that is checked is passed at the first argument. So here the function is checking for 3 old event number. So in this case, it's very easy. So, but the thing with the new KST and new event plus plus and the UTS event, things become more complex because the actual kernel function in this case are checking for event ID. So we don't know how to map those actual event ID to the actual event name. So for example, here in the 3rd argument and 4th argument of this function, they are checking for event number, event ID, and the event plus plus are using event names. So how to go from this actual event ID to those event names? That's what pretty complex to do, but I needed to start with a known case that hopefully I found with trial and error. I have found that, for example, the trace, which is the event plus trace, correspond to the actual this event ID, and the DMN compound for is correspond to the other event ID, and I have detailed this much in my blog. So the second step will be to find how Oracle is doing that under the hood. How which kernel function is used for translating this event name to the actual event ID. So this may seem too complex, but in reality it is very easy to do. All you have to do is put a tracer for the Oracle process. So you're going to trace what's going under the hood, and then enable the tracing DMN compound. And then all you have to do is take this trace file and check for any occurrence of our event ID. So based on that, I have spotted 2 interesting functions. The function store event ID by name, which call the function get definition by name. So basically, whenever we enable any event in the event plus plus event in the database, this function gonna be called and gonna return the actual event ID. So all we have to do then is enable all the event, the plus plus that we have in our Oracle database, and using a small gtrace script, we can get the return value of the function, which is actually the event ID. So if enable, for example, the tracing for DMN compound, I have the actual event ID of the trace event and the DMN compound, and then for SQL trace, I have the event ID of the SQL trace. So I did this for all the event inside the database, and then based on that, I was able to build the file event ID to event name. So whenever a function is checking for an event ID, so you can extract the event ID from any kernel function that is checking, and using this file, you can map them back to the actual event name here. So basically, that's all we need to finish our mapping file. Okay, so that's it. You have here the old event number, KST event, event ++, any event, check it, even undocumented event. This file can be downloaded from GitHub repository, and I have one for 19C and one for 18, I think. Okay, I finished, I think. 5 minutes? What?